Good morning to one all present here. Today I am going to talk about total angular momentum in many atoms. Each electron in an atom has a certain orbital angular momentum L and a certain spin angular momentum S, both of which contribute to the total angular momentum J of the atom. Let us first consider an atom whose angular momentum is provided by a single electron. Atoms of the elements in group 1 of the periodic table like hydrogen, lithium, sodium and so on are of this kind. They have single electrons outside closed inner shells, and the exclusion principle ensures that the total angular momentum and magnetic moment of a closed shell are zero. Also in this category are the ions He plus, Be plus, Mg plus, B2 plus and Al2 plus. In these atoms and ions, the outer electron's total angular momentum J is the vector sum of L and S. Therefore, J equal to L plus S. Like all angular momenta, J is quantized in both magnitude and direction. The magnitude of J is given by J equal to root of J into J plus 1 H cross J equal to L plus S equal to 1 plus or minus 1 by 2. If L equal to 0, J has the single value J equal to 1 by 2. The component Jz of J in the Z direction is given by Jz equal to Mj cross Mj equal to minus J or minus J plus 1, or it can be J minus 1 J, etc. Because of the simultaneous quantization of J, L and S, they can have only certain specific relative orientations. This is a general conclusion in the case of one electron atom. There are only two relative orientations possible. One relative orientation corresponds to J equal to L plus S, so that J is greater than L, and the other to J equal to L plus S, so that J is less than L. The two ways in which L and S can combine to form J when L equal to 1. Evidently, the orbital and spin angular momentum vectors can never be exactly parallel or antiparallel to each other or to the total angular momentum vector. The angular momenta L and S interact magnetically. If there is no external magnetic field, the total angular momentum J is conserved in magnitude and direction, and the effect of internal torque is the precession of L and S around the direction of their resultant J. If there is an external magnetic field B present, then J presses about the direction of B, while L and S continue precessing about J. The precession of J about B is what gives rise to the anomalous Zeeman effect. Since different orientations of J involve slightly different energies in the presence of B. Here we can see the two ways in which L and S can be added to form J when L equal to 1 and S equal to 1 by 2. J equal to L plus S gives 3 by 2 and J equal to L minus S gives the value 1 by 2. Here we can see the space quantization of total angular momenta when the orbital angular momentum is L equal to 1. The total angular momentum of an atom. If J and Mj are quantum numbers for the single electron, that is hydrogen atom, J equal to root of J into J plus 1 H cross, Jz equal to Mj H cross. Quantization of the magnitudes, L equal to root of L into L plus 1 H cross, S equal to root of S into S plus 1 h cross, J equal to root of J into J plus 1 h cross. The total angular momentum quantum number for the single electron can only have the values J equal to L plus or minus S, that is J equal to L plus S and J equal to L minus S. Total angular momentum. If there is no external magnetic field, the total angular momentum J is conserved in magnitude and direction, and the effect of internal torques in the precession of L and S around the direction of the resultant J. Only Jz can be known because the uncertainty principle forbids Jx or Jy from being known at the same time as Jz. Total angular momentum. If there is an with an internal magnetic field, J will precess about B external. If there is an external magnetic field B present, then J presses about the direction of B while L and S continue in precessing about J. The precession of J and B is what? J about B is what give rise to anomalous Zeeman effect as said earlier. Since different orientations of J involve slightly different energies in the presence of B. Many electron atoms. The total spin angular momentum S should be maximized to the extent possible without violating the Pauli's exclusion principle. In so far as rule 1 is not violated, L should be maximized for atoms having subshells less than half full. J should be minimized for labeled 2 electrons atoms J equal to L1 plus L2 plus S1 plus S2. There are LS coupling and JJ coupling to combine for angular momentum. Thank you.